In game theory, rule of dominance is taken. The following table represents the payoff matrix with respect to player A. Solve it optimally using pure strategy and dominance property. Here, if we observe the strategies for player A, there are 4 strategies, and for player B, there are 5 strategies. And in every row, we consider the row minimum value. So the minimum of these are 4, and from these it is 5, and here it is 8, here it is 4. And coming to the columns, we consider the column maximum. So here the maximum value is 8, 9, 11, 10, 10. Here, after this is done, I will write the maximum of this minimum is 8, and here minimum of this maximum, again it is 8. So when maximin is equal to minimax, it is said to be a pure strategy, and the value of the game is taken as 8. The value of the game is taken as 8, and the strategies for player A and B are the probabilities are here where 8 occurs is being considered, and for player A 8 occurs in third position. For player A 8 occurs in third position. So as it is a pure strategy, there 1 will be taken and the remaining are taken as 0. And for player B, there are 5 strategies in which the first one will be taken as 1 and the remaining will be taken as 0. Those gives the strategies for player A and player B. Right. Next, we solve this by using the dominance rule. For solving by dominance rule, we add all the elements of rows, and adding 4 plus 6 is 10, 10, 15, 15, 25, and plus 6 is 31. In this way, all are being added, and then what we do is we will find the minimum value. Here 30 is the minimum, and when I compared with the first row, 6 is greater than 4. 4 is not greater than 6. So we move to the second row. And if we observe, 6 is less than 7, 4 is less than 8, but 10 is not less than 5. Now we move to the third row. If I move to the third row, what I observe is 6 is less than 8, 4 is less than 9, 10 is less than 11, 6 is less than 10, and 4 is less than 9. So this row is dominated by R3. So R4 is cancelled. Now the next least element is being selected, which is next least is 31. That value is being selected, and now in the same way I compare with R2. 4 is less than 7, 6 is less than, and 5 is less than 5, but 10 is not less than 9. So I move to the third row. 4 is less than 8, 6 is less than 9, 5 is less than 11, 10 is equal to 10, 6 is less than 9. So this row is dominating this. So I will cancel the first row, and whatever are left, 2 and 3 rows are considered and the columns are considered, and again I add the elements 7 plus 8 15, 8 plus 9 17. From these I will consider the highest value. In the rows I will be considering the least, in columns I will be considering the highest. In rows the least will be eliminated, in columns the highest will be eliminated. Now coming to the first highest value is 19, and here 10 is greater than 7, 9 is greater than 8. Comparing C5 with C1, this is dominated. So this can be deleted. And next highest is 19. In 19, 9 is greater than 7 and 10 is greater than 8. So this can also be cancelled. And the next highest is 8 and 9. 8 is greater than 7, 9 is greater than 8. So this can also be cancelled. And we are left with 2 by 2. Next highest is 16, but 5 is less than 7, but 11 is not less than 8. So this cannot work out. So we move to the next step. What we do is, again we calculate the sum of the rows, and the least in the rows is considered. And for this 7 is less than 8, 5 is less than 11, so this will be deleted, and whatever is left were the some values. So here 11, that 11 is greater than 8, so this is cancelled, and where we left is 3 1 for B 1 position, and for A it is third position. So in third position it is 1 for A, and for B it is the first position. That will give the probabilities of A and B, and the value of the game is 8. Thank you.